Hi, and welcome to this flipped instructional session. This is Semester B of Earth Science, and today our topic is Lesson 2.04 and 2.05, Ocean Water. If you are using the note-taking guide, which is highly recommended, today we will be answering many of these questions during this recording, and this is a great opportunity to pause and fill in your note-taking guide. So let's get started. There are three factors that determine the composition of ocean water. The first is salinity. Salinity is, the base word is salt. So salinity is the number of grams of salt in 1 kilogram of water. And this can increase, which would be more salt in the water, or decrease, which would mean there's less salt in the water. Density is the concentration of matter. As you can see down here, these are two blocks with different densities. This one on the left is less dense because the matter is less concentrated. There's fewer molecules. This block is more dense because the matter is more concentrated and there's more molecules squished into one space. Then finally we have temperature, the degree of heat present. We sometimes look at this as cold or hot. So each of these factors varies as you move from place to place across the surface of the ocean. You can see that the water is much colder up at the poles than it is at the equator, or as you move deeper in the ocean, which we're going to talk about today. So first, salinity. Ocean water salinity is measured in grams of salt per kilogram of water. Ocean water has a salinity of, on average, of 34.5 grams per kilogram of water. Just to give you an idea of how much salt that is, if we took all the salt from the oceans and spread it over the land, it would be 150 meters thick everywhere, across every piece of land, worldwide. So that's an amazing fact. So how does the salt content vary in ocean water? So the first way it can vary is with evaporation. As we learned in earlier lessons, evaporation is when water molecules, which is H2O, absorb energy and evaporate or turn into a gas. As we look at this diagram, when water molecules evaporate, the salt is left behind. Salt can't evaporate because salt is a solid and has a much different temperature that it evaporates at. This increases the salinity of the water because as the water evaporates, the salt is left behind, making the water saltier. As you can see in this picture, only the water molecules are leaving, the salt is left behind. So another way this impacts it is because evaporation occurs more frequently where there are low levels of humidity. So an area that's less humid, there's going to be a lot more evaporation and the water is going to be a lot saltier. Because the less the water is in the air, the more water can evaporate. So that would just be one more fact to note about evaporation. Next, salinity varies with freezing and melting of ocean water, especially glaciers. So during the summer months, when the glaciers get warmed up, the frozen water melts. This creates more fresh water. This decreases the salt content of the water because as fresh water is added, the ocean water is less salty because there's less salt. The opposite happens in the winter months. During the winter months, the water is colder and more water freezes into the glaciers. That makes less fresh water. So this is kind of similar to evaporation. As you can see here, as the water molecules freeze into ice, the salt is left behind, and that increases the salinity because of the salt that is left behind. Another way the saltiness of water varies is through rivers and precipitation, such as rain. As rivers enter into the ocean, rivers are fresh water, so that is adding fresh water to the ocean, decreasing salinity. As it rains, as we talked about, only water evaporates and then precipitates back down. So as it rains, that also adds fresh water to the ocean, decreasing the salinity or the saltiness of the water. So now that we've talked about the saltiness of the water, we're going to talk about the ocean water temperature. So a question to ask yourself is, where would you rather swim? In Alaska or the Galapagos Islands? The answer would be the Galapagos Islands because it is near the equator and the water is warm. So at lower latitudes, for example, as you can see on the second map here, lower latitudes are at 0 degrees. The water is much warmer at lower latitudes. At higher latitudes near the poles, for example, at 80 degrees here near the North Pole and at 80 degrees here near the South Pole, the water is much colder. So lower latitudes, warmer water, higher latitudes, colder water. So that's one way ocean water temperature varies by latitude. Now we're going to talk about the depth of the ocean. Temperature, pressure, and density vary with the depth of the ocean water. The temperature decreases or gets colder as you go deeper. Why? Because less sunlight can reach down there to warm the water. So as you go deeper into the ocean, here, if we are thinking about going deeper, the deeper you get, the colder it is. The density, or how squished together the molecules are, increase as you go deeper. That's because the water is colder and saltier, making the water denser. Finally, the pressure increases as you go down. As the more water is pushing down on you, the higher the pressure is. You might have experienced this in a swimming pool. As you go deeper in a swimming pool, the water pressure pushes on your ears more if you've ever tried to dive deep. It's the same thing in the ocean. The deeper you go in the ocean, the more water that is pushing down and making the pressure higher. Finally, the layers of the ocean. Scientists divide the layers of the ocean into 3 layers based on density, pressure, and temperature, as we just talked about. Deep, cold water is the densest. The warm, shallow water is the least dense. And then we have a moderately dense layer here in the middle. Next, we're going to talk about how temperature affects density. The more things heat up, the less dense they are. So ocean water absorbs heat energy from the sun and the air as the air blows across the cool water at the surface. Warm water is less dense, and the molecules are further apart. As the water gets colder and deeper, the cold, more dense molecules bunch close together, as you can see in this picture here on the right. Finally, we're going to relate salinity to density. So we've talked a lot about the saltiness. The more salt in the water, the denser the water is. Salty, dense water sinks to the bottom. As the water temperature decreases, the water density increases. So both the salinity and the temperature of the water make the water at the bottom of the ocean the most dense. That's all for today. I hope you join me for the flipped follow-up. Thanks for watching and have a great day.